We're looking at our mile marker 4, practice 1, question 4. We're still working with the equation of a circle, but we're given an equation in expanded form, and we're required to use some algebraic factoring to get it in standard form. And the purpose of doing this is that's the form we would need it in if we were going to graph it using its center and radius. So a couple of steps here. Sorry, I'm trying to rearrange the way I'm holding my camera. A couple of steps here. And the first step is that we generally want to group our like terms together. So I want to regroup so that I have x squared and 4x together in parentheses, y squared and 8y together in parentheses, and this constant term right here, minus 100, I want to move my constants all to the other side of the equal sign. You can break that into multiple steps, but I think it's pretty easy to do in one step. So x squared plus 4x should be grouped, and we're going to put those in parentheses. Plus, don't forget your plus sign there, y squared plus 8y. And now we got to consider, what do we do to get this 100 to the other side? And when it gets there, will it be a positive 100 or a negative 100? If you look at this on the left side of my equation, 100 is being subtracted. So if you recall from what you learned about solving equations in algebra, the only way to really move this over there is by the opposite operation, addition. So I'm going to add 100 to both sides. When I do that, those cancel out, and we no longer have a constant term on the left side of our equation. 0 plus 100 is 100, so now we're good to go. Okay, the next step is where this actual completing the square comes in. So when we say completing the square, we mean in both of these binomials, I have two binomial expressions, I want to think, what could I add to them, to each one individually? What third term would turn this into a perfect square trinomial? And remember, we can't just go adding stuff to one side of our equation. It's like if you were putting weight on a barbell and you only put it on one side, not the other. Well, that's going to be unfortunate when you go to lift that weight. So what we need to consider is what number has to go here. Remember that to find our third term of a perfect square trinomial, we can really look at the second term. We could see the x came from our first term, x squared. So I'm really going to focus in on that coefficient of x, that 4. Divide it by 2. So 4 divided by 2 is 2. Then square the number you get. So 4 divided by 2 is 2, but 2 squared is 4. So this will be a 4. Now, because I added 4 to the left side of my equation, I have to balance it by adding 4 to the right. We're going to do the same thing with our y squared plus 8y binomial. And again, 8 divided by 2 is 4. 4 squared is 16. So 16 is what makes this a perfect square trinomial. And we're going to also add 16 to the right, because what I do to the left, I must do to the right. All right, from here, it should be a little easier. If you remember how we factor a perfect square trinomial, that was one of our special cases in Algebra 1. You're going to take the square root of the first term, so the square root of x squared is x. You're going to take the sign of the second term. So if that term is being added, we're going to keep addition. Then you're going to take the square root of the last term. So the square root of 4 is 2. And then that linear binomial that we get, we know that it would really be x plus 2 times x plus 2 when we factor that. So we write that as x plus 2 squared. All right, moving on to our y. We keep our plus sign there. The square root of y squared is y. We don't have to look at our entire middle term, but we need this sign here. It's addition. And then the square root of 16 is 4. And again, that's going to be squared. The only thing we have to do on the right now, if we haven't already, we need to combine our like terms. So that's going to be 100 plus 4 plus 16. I know 4 and 16 is 20, so that's 120. Okay, we're almost done. Oh wait, nope, we are done. I lied. That's our final equation. I'm just going to rewrite it neatly on the line. You know your geometry teacher would love to see your equation actually on the line as we grade your mile markers. Now, if we needed to, we could identify the center and radius here, but we don't have to take it that far in question number 4.